clock to measure short time intervals. In this experiment, we're going to do things just a bit differently. Now that we know the speed of sound, we're going to use that particular value to measure short time intervals. And the short time interval that we're going to measure is the amount of time it takes this balloon to pop. From the instant that I prick the balloon with this pin until the balloon is pretty much completely gone, that's the amount of time that we're going to determine. You might call that the lifetime of a bursting balloon. The experiment will use some of the same equipment as in the last experiment. A sound trigger connected to this flash unit, and then the 2 meter sticks that we'll use to measure distance. To begin the experiment, I'll be putting the balloon right here at the 0 mark of the meter stick. I'll pop it right at the front. It won't take very long for the sound to travel from the point where I prick the balloon to the sound trigger. In that amount of time, the balloon won't rip very far. It will still be pretty much an intact balloon. But then I'm going to move the balloon further and further down the meter stick. And the further I move it while keeping the sound trigger in the same place, the longer it will take sound to travel from the balloon to the trigger, and so more time will elapse. About how much time are we talking about? Well, from the last experiment, you probably found that the speed of sound was about 340 meters per second. Now, that's also the same thing as 340 millimeters per millisecond. Now, it's useful to think of it in those units because of the fact that we're going to be dealing with very short time intervals that are on the order of milliseconds rather than seconds. For example, if I move the balloon from the 0 mark to about 1/3 of a meter, well, 1/3 of a meter is 33 centimeters, and that's 330 millimeters. If the speed of sound is 340 millimeters per millisecond, that amount of time for sound to travel this far is just about 1 millisecond. So if, for example, the balloon were, let's say, 2/3 of the way down the meter stick, and we popped it, and we saw that the balloon was pretty much gone at that point, we could say, well, that took about 2 milliseconds because each third of a meter is a millisecond of time. Okay? So we'll use that in order to figure out the lifetime of this bursting balloon. So let's begin. We'll do a series of 4 bursts, one at 0, one at 1/2 a meter, and one at 1 meter, and one at 1.5 meters. And then we'll see what results we get from those. So let's begin with the first one. Here goes. So in the freeze frame, you saw that the balloon had split just a very short distance up the front of it, and that's because the amount of time it took sound to travel from the point of the rip to the microphone on the sound trigger was very short. Next, I'll move the balloon, the next balloon, 1/2 meter down the stick, and we'll do it again. But I'm going to move my flash down just a little bit so it's closer. But I'm keeping the sound trigger in the same place. Okay, let's try this one. Well, in that particular shot, you saw that the balloon was ripped completely up the front and actually ripping on the back. So the balloon was about half gone. Let's keep moving on down the meter stick. Well, that time the balloon was pretty much gone, but it still had a little bit of a shape of the balloon. So let's move down another 1/2 meter for the final shot. Well, in that last shot, you can see that the balloon was almost completely gone. There was just a little piece left, and it was completely collapsed. So we can say that the lifetime of a bursting balloon, at least the balloons that I'm using here, is about the amount of time it takes sound to travel a distance of 1.5 meters. So knowing the speed of sound and that distance,